Hello guys, we discuss machine learning, logistic regression, and multilinear regression, and the KNN method. So follow me in this video and subscribe to the channel to reach every important video you upload in these topics. Stock market, using programming in stock analysis and prediction, Egyptian stock market and programming, and fixing and repairing electronic and electrical devices. Moreover, I put and attach jobs and grants and scholarships for students. So the logistic regression and classification. Logistic, it's not like linear regression, it's a logistic regression. It's like 0 and 1, true or false regression. So we are going to classification. So it's like email, spam, non-spam, online transaction, fraud, not fraud, and so on. So we have two options here, true or false, or 1 or 0, and so on. So here, if we have a line regression, we have a line pass with the points, but here the line will separate the false points and the true points, or the white points and the black points. So we have two sides of points, and the line here, the regression will separate these points. So if these points over than 0.5, this is a threshold, so it's true, it's 1. If it's less than 0.5, the threshold, it's 0, it's false. This is the each of theta of x greater than 0 or equal and less or equal than 1. This is a logistic regression. Hypothesis, this is the hypothesis of the logistic regression. So interpreting hypothesis output, it's depend on the threshold. If the threshold is 0.7 or 0.6, this is the purpose, the hypothesis. Decision boundary, which is the line, this is the line which separate the above and down, or the right and left points to be on or off, or true or false. This also decision boundary. So the decision boundary here, this curve, this blue curve. So the thing is which is blue, this curve, and this will be this is for this is Z is positive. If Z is positive, so greater than 0.5, and that equals here theta transform time x, and this is multilinear regression. So we have theta transport, this is matrix, this transport matrix, it's multilinear, for multilinear regression. Decision boundary, these points, okay, in red color, and this cross in red color, and the circle in the blue color. So we suppose that we have this equation, which is theta of 0 plus theta 1 x1 plus theta 2 x2, and we have this g, which is the slope. So if theta of 0 is -3 and theta 1 minus plus 1 and theta 2 1, we have this line. This line is separating the red, this clustering, or this is classification, like the red cross and the blue circles here, y equal 1, the upper of the line, and this boundary line or boundary curve, and the lower is when y equal 0, or this is y equals, this is a false, and this is the upper is a true. Okay, and this happen when x1 greater than threshold, the threshold. So also we have another hypothesis. If this points in red color, the outer, and the inners, the blue circles, so this curve here is approximately the circle curve, x1 square plus x2 square equals 1 or greater than 1. Okay, here training set, the cost function, x belong to x0, x1, xn, or n the number of features, the number, it's the matrix. So this is the cost, which is h theta of x, it's equals 1 over 1 plus e power 2 minus theta transport times x times the array or the matrix of features, and theta is a coefficients, okay, theta from theta 0 till theta n. Okay, so we have here training set, training of x1, y1, x2, y2, and so on until x of n or x of m, y of m. Okay, and this is the multi regression, because we have n features. It's polynomial. It's not line regression. It's not line equation. It's not first degree equation. It's polynomial equations. It's not what equation. It's different equations. So here the cost function, j of theta equals 1 over m, the summation from I1 till m, half theta, h of theta times x y minus y all power 2. So here this is the function is h cos of h theta of x y. This is this is the cost function, this one. Here we have this the convex, while this is not convex, and then when we get this error, this is cost, the summation of cost here. So we have two sides of this to get classification for 0 and 1. So here if y equals 1, so we have h of theta in this area. Okay, if y equals 1, this is a false. H of theta is very minimum here. It's very minimum, approximately. No. H of theta, h of x, it's here in this. H of 1 is it's here, but here it's if y equals 0, we have h of theta, this one, minus log h of theta of x. While if y equal 1, this one, if y equal 1, we have minus log h of theta of x. This one, this is the curve of h of theta minus log of h of theta of x, where h of theta of x, this one, h of theta of x is this term. Okay, so here we have log minus log, where if y equal 1, minus log times 1 minus h of theta of x if y equals 0. If we add these two, we will go to the vertex. Convex equation. Okay. Now, in summary, this is the both equations here. We sum these two equations, but know that if y equal 1, we have this part. If y equals 0, we have this part. Okay? So this is a summation of the two sides. To fit parameter theta, cos of theta minimum, output of h of theta اللي هي ديت الايكويشن ديت اللي هي e power to minus theta transport times x array or matrix. Now you will hypothesize and repeat this until we have fixed theta of j. When theta of j, the error is fixed, no variation, this is the minimum error. Steady, no variations. So we have this when theta of j equals 0, or sorry, no variation, fixed. When repeat these parameters inside, and we get output theta of j the same or very small variation, we have the performance. We can take this equation and use in our regression, okay, for separating the points for true and other points for negative or for false. Okay. Then we have the KNN. The KNN, which is KNN algorithm. How does it works? Why we need KNN? This how do we choose the factor K? What is equal? When do we use KNN? And what does KNN algorithm works? Use case. So the algorithm used in machine learning model. So we have input value and we have predicted output. Then we have classification. This also used in classification. So KNN used in classification. It's near to the logistic regression or classification. So this cat, what's in black color, it's near from these 4 cats more than this on just one dog but 4 cats. So it's in this direction. It's here we have the space or the distance. We take the distance. This distance, it's one feature. Maybe there are other features like the shape, like the weight, like the different. So when this cat is near one feature more than one time or in times more than the other, so it will go in this side. So this is the input value, and we have here the KNN, the comparison, and the predicted output here. It's cat or dog or rabbit. Okay. It depends on the feature and the distance and the relation between this feature, the feature of this input, and the features of the surrounding or highly surrounding. KNN nearest. KNN stands for nearest neighbors. nearest neighbors اللي هو أقرب الجيران is one of the simplest supervised machine. One of the simplest supervised machine. It's a supervised machine. It's for classification. It's supervised. It's not unsupervised. It's supervised for classification. It's supervised, simplest supervised machine learning algorithms mostly used for classification based on the key neighbors. Key اللي هي nearest neighbors. KNN. K nearest neighbors. K is a coefficient. It's a number. And how to select this number. So this number may be 3, 5, 4, 10. K is a parameter. It's a coefficient or parameter. In the KNN, K nearest neighbors refer to the number of nearest neighbors to include in the majority voting process. So it's depending on the majority voting. If the voting is increased, so it will go to the increased voting, in the side of increased voting on this feature. KNN algorithm is based on features similarity. Choosing the right value of K is a process called parameter tuning. To select the right value of K is a process called parameter tuning, and it's important for better accuracy. So parameter tuning is very important for the better accuracy. Here, this is new variable, and where this will go, it will go to the red boxes or these triangles. So here in this circle, so this it's nearest to this. There is two boxes near, two nearest neighbors of red colors, while one of the triangle. So F3, K3, so it's red box. So if it's 7, if K7, so we have 3 in red box, while we have 4 in the triangle. So the new variable here will be go to the triangle. So depends on K, 3 or 7. It's very important. Key value of key parameter selected on key parameter is very important. How to choose key? Square of n, where n is the total number of data points. يبقى the square of n, where n is the total number of data points. Odd value of key is selected to avoid confusion between two classes of that. So دائما وابدا, never ever, K is odd value. It's not even value. Okay, this one is good. So how to select K? It depends on this function, elbow method. Elbow, it means كوع, شكل الكوع. So when this elbow method, this is the destination and this is the value of key. So here from 3.5 until approximately 0.8. Here this is the elbow joint. It don't make difference in this area because no log or big variation in this area, but the variation in this one. So K equals 3 is very good. Why K equals 3 is very good? Because here you have just 2 of the 4, while here you have 4 of 1 of 5. Okay, you have here 3 of 4 while here you have 4 or 5. So case 3 is more reliable. هنا make a difference, right? It's wider, no big difference. Okay. 5, if K is 5, you cannot get K is 5 here. K is 5 is not allowed. No. So it will give K of 4, not allowed. K of 7, it's in the limit. You are in the limit. Okay? You are in the boundary. Okay? In the boundary. You take all the samples. Here, it's like here. If you go here, no boundary here. No big difference, but this is the good. Okay? Elbow method. When to use KNN? When data is labeled, when supervised learning. Data is noise free, no noise in data, no confusion of data. Data is small, as the KNN is a lazy learner. Data is small, as the KNN is a lazy learner, does not learn discriminative features. Here we have, how does KNN algorithm work here? We have the weight and the height. The weight and the height and the class. So underweight, this is underweight. And this one is underweight. While all this is normal weight. Okay? This normal weight. While this is underweight and this is underweight. So here I have A or B, X, Y. To find the nearest neighbors, we will have to calculate the Euclidean distance. Euclidean distance, which is the root mean square of x minus a square plus y minus b square. This point, we take this distance. Okay, it's very easy. Which is called Euclidean or Euclidean distance. So we can calculate distance d1 and d2 and d3 from this thread point. The thread point and d1, d2, d3, calculate them and see. We have 6.7, 13 and 13.4. So now we will calculate Euclidean distance of unknown data point from all the point in the data set. Okay. There, if k equals 3, the normal, we are approximately near 1.4 with 3 and 2, and this is normal weight. So here this is normal, so this point is near those ones, Euclidean distance. Okay. Conclusion: a positive integer k is specified along with a new sample. We select the k entries in out database which are closest to the new sample. We find the most common classification of these entries. The classification we give to the new sample. Thanks for watching. If you have any question, ask and don't hesitate. Thanks for watching. So if we go to how to practice this, using the code. We open here the this is the code, connect here, and we have to import this import library, numpy library, pandas, matplot library, sklearn libraries, and from sklearn we have dataset to create a random dataset, sklearn model selection to import train test split, sklearn model learn logistic regression, sklearn matrix to import accuracy score, confusion matrix, confusion matrix display, precision score, recall score, F1 score. Then we will generate data randomly using this in samples 200, in features 2, in informative 2, and in random 0. And then split this data using xtrain, xtest, ytrain, ytest, train test split this function, and input this x and y, and test size is 0.3 with random state 42. Create logistic regression model. So we will create the logistic regression model and then train the model using the fit function, and then predict y, predict the model, predict x test, and then calculate the ACC اللي هي accuracy score, y test و y prediction والprint، وبعد كده then calculate CM الconfusion matrix اللي هو y test و y prediction و CM confusion matrix اللي هي دي برضو احنا حسبناها. So we delete one of them. We do this. Okay. With the same display plot, and then the plotting here, and then we will use this data also to reshape. Then for the KNN, K nearest neighbor classifier, we use it for these other functions. And thanks for watching the video. If you have any question, don't hesitate to ask me and I will reply you as soon as possible.